Okay, I think it's almost time. Maybe one more minute, waiting for everyone to join. Welcome to the first vegetable grafting webinar. I'm Cherry Kubota from Ohio State University. I'm sitting in my office in Columbus, Ohio. Um, I can see multiple friendly names in this webinar platform, so I really like to welcome and thank you for participating first webinar. So I just wanted to give a little bit of background why we are doing this quickly using a few slides and then turning that microphone and video to today's presenter, Kusakabe Kikai Corporation engineering team. Again, welcome. So as you know, grafting can join two different genotypes. One is for fruiting vegetable production. The other one is a strong rootstock to disease and then also environmental stress and creating sort of new type of plants that can enhance yield and then also resistance. So that's a basic idea. US is still relatively slow in terms of developing that usage and knowledge and technology. So a group of scientists in universities right now, 10 universities, or actually not just universities, including USDA research centers, um, got together. So the total of nearly 40 people working on this, introducing vegetable grafting technologies in US to support US fruiting vegetable industry. So this whole big group is led by Dr. Frank Lowe's. I don't think he can make it today, but he will be giving a presentation. He's a plant pathologist at NC State, North Carolina State University, and taking the leadership of this large group, working together to develop this new industry and usage of grafted plants. So this is one of our efforts, particularly for outreach or extension efforts. Monthly webinar series we will be doing every month. So this month and then next month, November, we'll be focusing more on grafting technologies. And then I don't think we will be doing any webinar in December because of the holiday season. But January, February webinars, we will be doing webinars focusing on efficacy of grafted plants. And then March and April webinars, we are thinking managing grafted plants, so how to use grafted plants in the field. And then May and beyond, more topics are going on. It's going to be a good learning opportunities for everyone. Um, and I'm so glad I can host the first one um, with Japanese group, which I came from. So additional information, this grafting SCRI grafting CAP group is organizing not just the outreach extension type of activities, but also scientific conference, which is coming up in July under aegis of International Society for Horticultural Science, ISHS. And this is going to be International Vegetable Grafting Symposium. Um, it's going to be in Charlotte, North Carolina, July 14th to 18th. So that's another great opportunity to learn about the current status of sciences and technologies there. So with that, I don't want to take up too much of time. Therefore, I like to go to the group sitting in Osaka, Kusakabe Kikai Corporation. So I think we are going to have the first, going to have a president, Mr. Minohara, to give a little greeting to everyone in the webinar.
Start
Yes, we
now.
can hear.
Okay.
Yes.
Yes. 先に顔見てるの。
そうですね、自分の。
これ、顔がでかすぎるんじゃないこれ。
いや、ちょうどぐらいで出して。
このぐらいで見えるんですか読みますね。I'm Minohara, President of Sakabe Kikai Company. First, I would like to introduce our staff first. Okay. The Masaki, General Manager of Sales, Agriculture. Shimada, Mr. Shimada, Technical Project Manager. And Mr. Murakoshi, International Sales Manager. Minohara, Project Assistant Manager. Sugioka, Hiramasu, expert of seedling. Okay. Sugioka, mechanical engineer. Okay. So, 話すのはいいな、これ。Okay.
Okay, so Masaki-san, お願いします。Share.
So
right now it's actually 5 a.m. over there, so just give you a perspective.
はい。あれですね。俺が初めのプレゼンテーションちょっと初めにしよう。はい。工藤先生、ちょっと初めに2、3分だけ、1、2分だけ僕ちょっと一言言いたいんですけど。
はい、どうぞ。お願いします。
はい。I'm Minohara again, the president of Sakabe Kikai Company, Limited, Osaka. At first, I'd like to express our thanks for your participating in this meeting. And also, I would like to thank Professor Kubota to arrange this opportunity for us. We'll give the presentation about our developed grafting machine, RoboGRF now. RoboGRF is useful, economical, compact, and the most practical machine. We hope and expect this machine will make easy to adapt the grafting method and improve your productivity of grafting. And also, as we are willing to make improvements with this machine by reflecting your opinions, I would appreciate your feedback on the machine. Thank you once again to be here today. Okay.
Yeah. はい、ありがとうございます。Thank you very much, Mr. Minohara.
画面見えてますか？
はい、大丈夫です。
Okay, good afternoon, everyone. We are Sakabe Kikai Company Limited. We introduce to you today our grafting robot and also the system we developed, which are actually running for production at the customer site in Japan. This is today's menu. The first, about us. The second, grafting machine lineup. The third, our compact grafting robot, RoboGRF. The fourth, we will show you the video. The fifth, about the benefit. And at the last, conclusion. About Sakabe. We are 52 years old, established in June 1966. We have been G licensee since 1972 and still have a good relationship with G and dealing with them. In fact, G is one of our good customers We manufacture special designed high-tech machines under their license and exported them to their overseas factory. As you see the map on the right side, and we have exported lots of special machines to overseas customers. Based on the expertise and the know-how accumulated in the past, we developed grafting machine. Next slide, we will introduce you our grafting machine lineup. Grafting machine lineup. We have two types of grafting machine. One is fully automatic graphic system. The other one is a robot GRF, semi-auto grafting robot. As we believe it might be a little easier for most customers to invest for rather robot GRF than the full auto system. We would like to explain this time mainly about robot GRF. Robot GRF. This video shows you the track time. Next one. This is the structure of the robot GRF. Let's look at the video of robot GRF. Okay. We explained. This is the scion clamp, this part. And the left side is scion cutting. And the root stock cutting here. And root stock clamp. And the clamp button. And the start button here. That's the structure. This is a way of movement of robot GRF. Good. We will explain about the operation and the machine movement step by step. The 1, 2, and finish. The first set root stock and the scion, and then push the first button. And you see the seedling will be held by machine hand. And push the second button, and the root stock and the scion will be cut and grafted. And clip will be set on. And the finished product will be output. And once the second button pushed, automatic movement starts and automatically ends.
もう一回見れますか？
First, insert seedling.
Grafting. Robot GRF is much more improving in 4 major concern issues which are observed at the past machine. The first one is how to stabilize grafting quality. Mechanically controlled, Robot GRF provides you stable routing efficiency, which is more than 95% based on the result at the customer site in Japan. The second one is high productivity. The Robot GRF provides you 3,000 pieces capability per day per person. Let's watch the video.
I have a quick question though. ちょっといいですか？一個前に戻っていただいていいですか？ So I have a question. 一つ前のスライド。Okay, never mind. Just go ahead. いいです。続けてください。
7.9秒なんですけどね。
ちょっともうやつ。Please see the number of the time, the right upside. This is actual time to spend. Yeah, more thanそれでいいんですよ。その7.9みたいな。見てる？
あ、向こうで、あ、こっちが隠れてるだけです。
こっちはモニターのために出してるからかな。
今回ね、そう説明したの、さっきのタイムしてるんですよ。これじゃあ先生なんかこれで質問があったんじゃないですか？
これですね、これですね。
Yes, I have a question here. What is the routing efficiency? Is that the success rate?
Yeah, success rate, yeah.
Success. Okay, for the graph.
Success rate in Japanese.
Okay, thank you.
High productivity.
The second one is high productivity. Global GIF provides you the 3,000 pieces capability per day per photo. Yeah. First time is 8 seconds per grafting, which means that 450 pieces per hour.
7.9 seconds.
Yes. The takt time is 7.9 seconds, nearly 8 seconds. Based on this takt time, 1 day output is 400. 1 day is 450 pieces. One day was more than 3,000. Sorry, I made a mistake. Yeah, 8 seconds by grafting means 1 hour of 450 you have. So 1 day more than 3,000. Sorry. Yeah, cost performance. Yeah, we continue. as our RoboGIF, the price is a very reasonable one, which is less than half in price in comparison with other manufacturers. Very cost effective. And RoboGIF does not require any qualification or any specific skill for grafting. Only others, while manual grafting requires both, along with training by veteran trainers. So anyone can master grafting with GRF, RoboGIF in just one day. If you were involved in the agricultural business, you may be reluctant to adopt high-tech agricultural machinery because you are always concerned about the maintenance. However, please be assured that this issue can be easily solved by replacement machine delivery. That's what we do actually in Japanese market. Next. Yeah, this is a master RoboGIF. As I explained in the previous slide, please watch the video, which shows you how she came to master grafting with RoboGIF. At day one, she met RoboGIF for the first time, you see. She's a little bit timid and nervous with RoboGIF. Day two, you see, she's operating RoboGIF smoothly and confidently because she's already mastered how to operate in just one day.
Same person, but different.
The same person, same person, different day. This is RoboGIF with conveyor. This is one example for RoboGIF with conveyor for your reference. Left one is 2 RoboGIF, 3 operators. The right one is 3 RoboGIF, 4 operators. As operator in charge of grafting can concentrate on only grafting, and he or she is not needed to put it back into the tray. That means total production volume will increase automatically. That is standards for scion and the root stock for RoboGIF. Whoever the operator may be, RoboGIF can accept, but it cannot accept all kinds of specification of seedlings. Please look at the RoboGIF standard specification at the right side. If your specification of seedlings are within the range of the standard, RoboGIF will provide you lots of benefits. Left side, the recommendation. The first one is the straighter the stem, the better. The second, the flatter. I can pronounce this word, COTIL, CO. 先生、これなんて発音するんでございましょうか。
コティレドン、コティレドン。
コティレドン、the better, as below. The third one is a solid stem, the better. Right side is a RoboGIF standard. Scion, a cutting position 15 millimeter below the first leaves. The full stem diameter should be minimum 1.6 millimeter, maximum 2.2 millimeter. 先生、まずすみません。これもちょっと発音できないです。エピコロ。Epicoral length, minimum 17 millimeter. About the rootstock, cutting position 35 millimeter from the soil. Stem diameter should be minimum 1.6 millimeter, max 2.2 millimeter.
Hypocoral.
Length. More than the 50 millimeter necessary. and the difference of diameter between scion and the rootstock should be within 0.5 millimeter. That's a standard. Conclusion. At the last, Lobo GRF is the lightest, the most compact, and the easiest machine to operate in the world. Anybody can start right now. Easy grafting with stable quality and high output with Lobo GRF. Thank you for listening.
Okay, thank you very much. So let's open up. So you can stop the sharing. スクリーンシェア終わりにしていただいて、いいですか? Okay, so I like to open to the everyone. You can ask questions using your microphone. I think you have control. So the icon down left is your muting, unmuting icon. So if you have questions, please do so now. Speak up.
Hi, my name is Suzette Calinato from Washington State University. I work at the School of Economic Sciences. My question is about the capacity constraint of the Robo-GRF in terms of the maximum number of grafts that will be done before the equipment would need to be replaced. Do you have an estimate of the capacity constraint of the Robo-GRF?
Capacity constraints. Could you, sorry, I don't.
Oh, what I meant is the maximum number of grafts that can be made before the Robo-GRF will have to be replaced.
Oh, so that, okay. We have to, so the before the Robo-GRF will have to be replaced. Okay.
So,
わかりますか?
How many people?
いや、何本ぐらいの苗を、最大で、継ぐことができて、要するに次の買い替えまで対応できる、なんていうんですかね。最大の、対応年数っていうか、まあ、対応本数でがあれば、本数でお願いしたいです。
この機械の寿命みたいなもんですか? この機械の寿命みたい。
あ、そうです。寿命です。寿命を本数で表せれば。
今の話で言うと、このパーツは交換したらそう。パーツを交換せなかったね。シリンダーとかのパーツが、メーカー保証がだいたい100万本か。100万回なんですね。
So usually for the critical parts, they can tolerate up to 1 million grafts.
それで、we have to replace those parts after 1 million grafting.
Then factory replacement?
Replace such a component.
Oh, parts, okay.
Part.
But the whole system can go more than that, correct? Longer than that.
Yes.
Only critical part, we have to replace it. The machine itself, it lasts more, I think.
And such as cylinder?
Yeah, air cylinder lifetime is just 1 million cycle. So it simply it lasts just 2 years or something like that.
Suzette, is that okay?
yes, thank you.
All right. Do you want to share the price information, Masaki-san? I think everyone wants to know that.
29,000 ドル。
$29,000 US dollar.
29,000 US dollars.
Yeah.
Anyone else?
Yes, this is Mahmoud Sultan. researcher in Agriculture Research Center in Egypt. My question is about the distance between the soil and the cutting place. So I think if it's 35, as we know that sometimes the rootstock, the cotyledon sometimes less than 35, and sometimes it's higher than this. So we now have issue of either adventitious root or sprouts from the rootstock. So how we can avoid this, or this is a standard that the machine is working?
So you are saying is if it
The
is
distance between,
yes, if it
yes.
is greater than that, then you have an issue of adventitious root.
Yes, if it's
Longer scion length having adventitious.
Yes, and another question is what you are grafting now is the standard from 1.6 until 2.2. I think sometimes you can't manage this to this. For example, it can be grafted until 3 millimeters. So if it's if the plants reach to 3 millimeters, can we graft this using a machine, or at this time it can't be grafted?
わかりますか質問。茎のサイズが2.2 より大きくなったとき。できるかどうか。So the maximum is 2.2. So that's the actually limitation of machine grafting. All the machines have the certain specification, the diameter size X to Y, the length, you know, C to W, whatever. That's typical to assure the 95% success. So that's typical, I think, in my understanding.
Yeah, just actually that is a standard specification. However, we can customize it. For example, stem diameter that up to 3 millimeter.
Customize is possible.
Yeah, we can meet the customer's request
based on their size, actual size. Okay.
逆にアメリカだとその K のサイズの標準のやつはどのくらいなんですか？
That's depend. So the question is that what is the typical size of the scion diameter and the rootstock diameter we see in U.S. nurseries, and that's I think also I think 1.6 and 2.2 can cover most of that, or maybe 2.5. I don't know if someone wants to make a comment on that. What's the typical size range you guys are grafting? Anyone want to inject that? I think most of them maybe in participating in this are users rather than nursery. Oh, okay. So there's a chat area. There's a comment that range is mostly okay. The price information is 29,000, not 59,000. So 29 grand, 29. So I would say this is a relatively low cost machine compared to others. Anyone? Question?
Hi, sorry, I'm joining late. My name is Margaret. I'm a researcher at Cornell working on tomato grafting. And so I missed some of the early information about the grafting robot, but is it capable of grafting other crops as well, like cucurbits? And then are there currently plant propagation companies or large scale efforts that are using the robot successfully that we could talk to about their experience?
最初の質問が、売りか、キュウリとかには使えるかどうかっていうので、二つ目の質問が、日本のどこかの会社がもう使ってらっしゃいますかという質問。
言い方が違うんで、開発テーマになったけど、この機会で
聞こえないです。もう一回言ってください。
売りかは、つなぐ、継ぎ方が違うんで、この装置ではできません。
So the for cucurbit,
開発になってますけど。開発する対象にはなってますけど、この装置では今できません。
So for cucurbits, this machine cannot handle because a totally different grafting method. However, they are planning to develop another machine that can handle cucurbit, watermelon, and melon and cucumber. So the second question, 2番目の質問の答えもお願いします。
テストで使ってて、来年の春に、本格的に、採用して使うという計画になってます。日本では3社。
So 3 companies have been testing that machines in Japan, and it's a trial status right now. But next year, in March, they are going to start using them for the real operation.
実際に注文をもらって今制作中ですけど、日本の場合は春と秋しかシーズンがないんで、次の実際の運用は次の春になる。
So Japan, the transplanting seasons are distinctly either in spring or in the fall. So the coming spring season is the one they are going to start using it.
Thank you.
Thank you for the questions. Anyone else? So there's a question I see about the disinfection, so the sterilizing parts of the machine. 消毒の質問です。ナイフとか、the cutters and razor blade.
消毒の機能自体はもう装置には持ってない。
So the machine doesn't have that or doesn't have that sterilization function, such as spraying disinfectant and things like that. It doesn't have it. So users, 使用者が気をつけてやらない。So the users need to do that periodically.
スプレーであれを刃がですね、切断の刃がですね、すぐに外せるようになってまして、そこですぐに掃除しやすいようになって、消毒しやすいようになって。
But the design, well, so the cutting part is designed so that it is easier to clean. So that's the machine characteristics, I guess. 切り方については説明が全然なかったんですけど、V 字カットのことは言わない方がいいんでしょうか？言った方がいいんでしょうか？
わからないんで出さなかったんです。それどっちがいいか。
よく聞こえない。
いやいや、それを今公開した方がいいかしない方がいいかよくわからなかったんで、特に。
そうです。はい、わかりました。
今内容したロイのなんかちょっと簡単な資料を作ってますんで、それをお見せしましょうか。リターンオブインベストメントのちょっとグラフみたいなの作ったんですけど。
どうぞ。
はい。
Anyone else? Oh, okay. So additional information here.
Return on investment.
And this is the Robo GRF, and the output operator, a number of operators, and the daily output, 8 hours, initial cost, and consumable. One is a clip, and the second one is a cutting blade, and labor cost, hourly $10, and annual output. Yeah, and this is manual grafting. So output Robo GRF, 450 pieces per hour, and manual. The skilled grafting operator is 150 per hour. Operator, just one person. And to catch up the 450, they need 3 people, 3 operators. Daily output is the same. Initial cost. Oh yeah, it's just wrong. 29,000 US dollar. Zero, manual zero. And the consumable clip, based on our calculation that we use, totally 81.
100日稼働で
Yeah, based on
大
the
体結論の
100 days
2年から3
working
年で
per year.
回収できます。
The conclusion is, second year, Robo GRF is, how can I say? 何歳ですかこれ、回収ができたの。
ペーバ
payback, yeah. Just 2 years. Robo GRF can be payback.
ーもうちょっと200、2万9千ドルもうちょっと下がるかもしれない。まあ、そういうね。で、これは年間の稼働率が100日というベースで。
Yeah. This is all the data based on the 100-day working day per year. This is the most important factor. 100 days working.
Actual working time, actual using time, actual operating days. The 100 days a year.
Okay.
そういうこと。質問なんかあれやるか。こっちからの質問。こっちから質問してみたら。ね。
So here's a question, another question. During commercial operation, how many plants can be grafted before you have to replace cutting blades? 何本ぐらいついたら刃を変えることになるんでしょうか。それが100万本ですか、それとももっと。
いや、刃はですね、一応1回5000本なんですね。5000本
So the recommended number of plants before replacing cutting blade is いくつでしたっけ？ 5,000 plants.
それであとは苗の硬さとか、その辺によってちょっと多少変わりますが、大体そういうぐらいですね。
That's also depending on the type of plants. So can this apply to eggplants also?
ですね、ナスの場合と、同じナス科なんですけども、先ほどの、苗の使用のあれがありましたね。あの範囲に入れば問題ない。
So that if eggplant, scion, and rootstock meet the whatever the specifications or requirement a machine has, then it can graft without any problem.
ただ、ナスの場合は、大体的にその茎が硬いんで、その今のカッティングブレードの寿命が多少は短く。
And then because eggplant, scion, rootstock has a little bit harder scion rootstock stem, therefore the blade exchange may be a little bit in shorter cycle. how many minutes does it take to clean machine parts that come in contact with plants? So 洗浄作業はどのぐらいの時間がかかるかという質問ですね。
基本的には歯だけなんですけど、基本的には歯だけなんですが、先ほど言ったように取り外しが簡単にできて、それずっとやるんで、おそらく1分か2分ぐらい。
The part that requires cleaning is just a laser blade there, and then also the design allowed a quick removal of the blade and then replacement or the put in a place again. So and then they are saying about 1 minute or so to do that whole process.
これ AI で出すと飛ばすのが終わったと思う。そのクリーンというか土とかですね、切った後の苗とか茎とかが、機械の中に散らばりますので、最終的には一番終わった時に、エアダストで、エアブローでクリーンする。
So, and then also they recommend that after the operation of the day, use the high pressure blower or whatever you call to clean off by air. It's like a cleaning machine to blow off the dust and debris and stuff like that. And there's another question. What about peppers? So, ピーマンとかそのあたりのはどうでしょ
う？ピーマンも同じナス科なんで、先ほどのあれと一緒ですね。ピーマンは柔らかいんで大丈夫だと思う。
Okay. So basically the same thing. As long as it fit that requirement, then it can handle quite well. And then that also customized. You can customize this based on your plant size. So there's another question. If you remember so it's another question about the requirement. So the requirement is usually either in the range or greater than this amount. And then that was a question, hypocoral needs to be certain lengths or not, but it actually, since I'm answering because I know the answer, it has to be longer than that. So the longer, there's no upper limitation. It's a minimum requirement for the hypocoral. 下配塾の方の使用は、最低の値だけですよね。だから、最低より長ければいいわけですよね。
そうです。ですね、6時分の長さのアッパーワールド、大幅にですね、例えば機械を材料を置くときにですね、いるところで長さが決まりますので、大幅にその短いのとか長いのとかいっぱいあるとちょっと難しいんですが、長いのなら長いのばっかりであれば、その機械はそれなりにカスタマイズできますので、
So the machine handle the long hypocoral easily, but if there's a huge variation between plants, then you may encounter some problem. And then, yeah, you guys, you know, chat area is not really efficient to ask questions. So if you feel comfortable, please use microphone. Oh, so another question. So they want to see again how the machine needs to be fed with scion and rootstock. So no process ですね。How those plants are fed. They want to see that again. I mean, one person wants to see that again. はい。 So I believe it was like a one upper and then one lower, and then upper one is Scion, lower one is
すごい。一つ一つのやつなんていいんじゃないどうやって
Can you share? Do you want me to share?
画面シェア。ちょっとその
Go ahead and share the screen.
現在のスライドが、なかなか、なかなかあれ。
次ですね。
はい。
台を置いて、ボディを置いて、それでここでクランプ。次のステップでまた置く。
Okay, so the first one is rootstock and then scion, and then push the button, and then do the rest. Okay. Questions regarding this? Anyone?
I have a question.
Sure.
So if we're interested in potentially purchasing a robot system for our campus for academic research, is it possible to come visit and test out the robot with our research genotypes or just see how it performs before investing in a purchase?
Okay. 大学なんかに来ていただいて、デモンストレーションしていただいたり、することってできるでしょうかという、大学の方なので質問があります。
はい、可能ですよ。はい。
That's possible demonstration in your campus.
Okay, so they could bring the robot to campus.
Right. 持ち歩きは結構簡単なんですよね。そういうこと。
そうですね。この装置自体の重さが、約45キロなんですね。
So the total weight of this system is 45 kilos. So it's about 90 pounds.
Okay.
So relatively easy compared to other machine to carry around.
Okay.
一人ではちょっと重たいですが、まあ、二人なら。
Maybe too heavy to carry by one person, but it's possible to do 2 persons.
Okay. So to bring if currently there's no grafting, none of these grafting robots in the U.S. Is that correct? They'd have to ship something here.
So the U.S. There are a couple of grafting machines distributed right now. One is the Dutch company called ISO's grafting machines, and those are probably, I don't know the current price, but it's quite high price, but a much faster speed.
Okay.
And the most recent model has either one person assisting or 2 person assisting the machine. And then I think it's 1,000 grafts per hour. Yeah. And then Korean one is 2 person assisting. And then that one has a flexibility. So tomato can be grafted, and then also watermelon can be grafted with that.
In that video. So there's researchers who currently have those robots.
Researchers some researchers, or at least I know one group has Korean robot. Richard Hassel group has that in Clemson University.
Okay.
That one I believe is the earlier model, so it's not the most recent one. That one is quite challenging to test in university. The reason is, number one, price point is very high, so not easy to acquire that. Number two is grafting speed is so fast. You you have to prepare thousands of plants to do 3 hours of demonstration, and then doing research is not easy.
Right. Yeah. So for this current Robo GRF, there are no models.
Nobody is using this.
Okay.
This is new. So I got to learn this machine 3 years ago when they are still very beginning of R&D for this. And then I invited them because I learned that they are ready to commercialize. Already, もう売ってるんでしたっけ？もう売ってますか？
はい、売ってます。
It's already commercialized, so that's why I thought I would invite.
Okay.
でもあとアメリカへのちょっとこれからの進出についてはですね、もうこの機械のメンテとかですね、そういうパートナーをちょっと見つけないとなかなか難しくなりますので、
Okay.
ちょっと時間がかかるのと、それからアメリカでもこのレンタルの方の、商売といいますか、そちらの方も始めようと。
日本ではレンタルされてるんですか？
はい。
So their business model has two options to get this technology out in the industry. One is selling this machine and provide service. Two is a rental service. So it's a lease program or rental program. So the nursery can rent this machine for period of time, and they pay monthly fee. Or whatever the fee program. So the two ways they do in Japan. In US or North America, they are thinking of expanding that business model in US also, but they haven't established a partnership, and they are currently looking for a good partner to do that business. So the selling and providing service and maybe rental business also. So that might be good for university demonstration or the extension program or the short period of time using this machine for research or extension programs.
Do they have an estimate of rental costs? I'm sure in the US it would be different.
Yeah. レンタルコストは日本では今いくらぐらいですか？ I'm asking Japanese rate now. 日本ではいくらですか
？8000円です。
月
1日です。
あ、1日。
はい。
So they charge per day, and then they charge $80 per day in Japan. And they haven't set the program or price in US yet.
あともう一つですね、メンテナンスのことなんですが、そのレンタル商売、レンタル機を持つことによってですね、もし購入いただいた、その機械が、壊れたという時には、レンタル機を代々としているような形で、メンテナンスの対応を可能にしていると思います。
So when it is in a rental or lease program, then they would replace the machine when something happens. So that's the current program they have in Japan. So I see my time and my clock is getting close to 5. Do you have any more questions?
先生、もしよかったら、そのさっき言ったフルオートマシンのちょっと最後ビデオをちょっとだけお見せしたいんですけど。
フロートマシン、はい、どうぞ。
いいですか？
はい。
ちょっと最後。
They want to show something very quick. エスケープキーで、エスケープで戻ってから、はい、選択していただいて、スライドを。でスライドショーを現在のスライドからに。
現在のスライドしてるんですか？なんかあれしたい。
これ星マークですね。
はい、そうです。
右下のスライドのボタン。これはどうですか？
全問、その右、もうちょっと右。これこれ、手がない。ちょっと諦めかんないけど、やっぱり。このオリジナルムービーはないの？日本語のやつ。日本でいいの？これですね。 見えてますか？
見えてます。So what are we looking at now? 何を見てるんですか、これは。
これが全体像で、これが大事ポジ、一番上、ちょっと言うと、一番上が
最後
の
ルーツストップ。ルーツストップ。
So I think what we are seeing is the automatic or full automation model they developed earlier. What's the speed of this grafting? スピードはどのくらいなんですか？ 800 grafts per hour. Okay. And then are you setting this too?
1台ほぼ内需もらってます。1台ほぼ注文もらってます。
They just sold one machine for that. So they have not just the one simple one, but the full automation version too.
これ画像処理の装置もつけて一緒に販売してます。
So it has a image analysis.
この装置はちょっと内のあれがちょっと狭いんですね。うちの次太郎というか、ロゴの GRF によります。で、それをですね、それをより分けるために選別装置というのがこの前のところにつくんですが、それは画像処理で選別して内容を分けていくという。
So this machine has a more specific requirement in terms of or narrow range of specifications for rootstock plants and scion plants. therefore, they have another process, which is selecting or sorting plants to get uniform stands.
そ
And
の装置が、この装置が受け入れなかった装置、苗を先のロゴ GFR で、今度は継ぐようなこともお客さんは実際の運用で考えてあります。
so I think it's getting close, or actually exceeding the original webinar time. So I'd like to conclude this. So the next webinar, well, thank you very much, 皆さん、日下部機械コーポレーション。I really appreciate. So the next webinar is going to be November 29th, I believe. And then we will have Dr. Ricardo Hernandez from North Carolina State University. And then he's going to talk about indoor production of high quality grafted plants. And then he's going to talk about benefits and energy optimization. So that's also unique technology. And then after that, we are going to talk about efficacies and management. So let's thank Masaki-san and everyone, Minohara-san, President Minohara, and everyone in Kusakabe Kikai Corporation from Tokyo. I mean, sorry, Osaka, Japan. Thank you.
Thank you very much.
All right.
Thank you very much.
All right. Thank you, everyone, staying with us for the webinar. And then I look forward to seeing you guys again for the next webinars. Thank you.
Thank you.
Thank you.
どうもありがとうございました。
Thank you.
ありがとうございました。
Thank you, Sherry. Thank you very much.
Thank you.
Thank you.